Okay, hi everyone. Welcome to the first session um, for this course. So, what is today's agenda is I'm going to give you a brief overview of the course, maybe the first 5 to 10 minutes, what you can expect and what is expected from you. And then we'll look at today's topic. For today's topic, I will cover the basic statistical analysis. For that, I have taken two case studies and I will share where you can download the data for today's session. And then I will also share you the link to the GitHub location from where you can actually download the code and you can go through the code. So what you can do is you can start with that. So those who have attended the Python primer session, they would have already seen the link. But for people who are not joined the primer session, just attending for the first time, I'll share the link with them. They can download the whole project from the GitHub location, and then we can run those notebooks today. Just to confirm, are you able to hear me properly? Am I audible?
Yes, Pradhan.
So, as I've already mentioned before, the course outline will contain three core areas. One is the data science and data engineering basics. Of course, the primary focus of the course is going to be machine learning, where majority of the time we'll be spending, and also ML ops. So this course is actually designed to kind of combine all three important areas of expertise that's required today. So today you can do the basic statistical inference and data science activities. And you also need to know some of the basic data engineering concepts, though of course this itself is a very large area. So we'll be focusing on some of the core concepts of data engineering, where the data scientists might have to tap data from for inference analysis or building machine learning models. Our core focus again is going to be machine learning concepts. So this will take about 6 to 7 weeks of time, and machine learning is going to be take the majority of the time, so about 8 to 10 weeks. And then we'll also look at ML ops concepts. What people are looking for industry today, it's someone who can build a model and also deploy and operationalize them. So the whole we'll look at some of the key concepts in ML ops, like model versioning, experiment tracking, deployment, and monitoring. So we'll actually deploy the model. We will probably use ML Azure, the Azure platform for that. But whenever I come to that particular point, I will announce that. So this course will combine all three important areas expertise. So you will actually get to know from a practical perspective how to do data analysis, build models, and deploy them as well. Okay. So there are of course tentative timeline, but more or less the time distribution would be like this in all three important topics. The course highlights, of course, uh, the whole course will take about 18 to 20 weeks. That comes out roughly around 5 to 6 months of time. And every week we'll have about 2 to 3 hours of live session, right? And those sessions will also be recorded for you to go and revise them. So those recorded videos will also be shared with you. And all the sessions, we will actually go through, applying the concepts that we learn in each of the session through a hands-on approach. So we'll actually, every session will run through some notebooks. We'll understand how to implement the concepts and ideas, right? For this, I'll be actually uploading all the files in the GitHub location, which I'm going to share the link now. And before the session, you can download them and keep it ready on your system so that you can go through each one of them. And all those notebooks will also have specific exercises or assignments at the end of each session. Okay, so every session will end up with some assignments. So my expectation is, of course, you'll go through the videos probably one more time and complete those assignments if you want to keep yourself updated and properly follow all the sessions. There'll also be quizzes at the end of every 2 to 3 sessions to kind of enforce some of the concepts that you've learned so far. As of now, the plan is to run the sessions on Friday evening and Saturday morning. But again, depends on how many people will ultimately end up taking the full course, because the first 4 sessions are free, and depending on that, I will probably consolidate. I'll take a survey and will consolidate into one session, or will probably keep it 2 sessions, right? So if I keep it 2 sessions, I repeat what is I will take on Friday evening on the Saturday morning. Depending on your convenience, you can join both either of the sessions. The participants should have a programming background, which is, of course, I have already mentioned before. Python programming is, of course, must. I have already done a Python primer session. The videos are already uploaded, and I have shared the link on the Discord group. If you're not familiar with the Python, you should have gone through that particular video, I'm expecting. A minimum commitment of 6 to 8 hours per week is required. So of course, you that inclusive of the session that you will attend. So another 3-4 hours of going to the videos again, and some of the readings I'm going to share, so you can actually go through those videos as well, the readings as well, and do the assignments on time. You should be ready to work with small groups, because there will be a project at the end, so you should be able to complete the project by forming a group. And you should take all quizzes and assignments on time. So this will actually ensure that we we progress in the right speed. So all the notebooks are going to be in the GitHub location. So this is the GitHub location. So let me share this link on the chat window, so you can actually keep track of it. Just give me a second. Yeah, so this is the I have shared it on the chat window. So if you open the GitHub link, this is actually a GitHub repo with called ML course V1. This is under my name. And what you can do is, you probably at the start of the session or just before the session, of course, each session you can download the whole zip file. The repo has a zip file, and this will of course include all the files that's there in the repo. Okay, so I've already created one called Python primer, in which there are 2 notebooks that we've already gone through in the first session. I mean the primer session. This is actually the first session, and for today's session I have actually created a few notebooks, so we'll go through them. Okay. I'm expecting that you would be very familiar with Anaconda or probably Google Colabs. We will actually using both the development environments. So if you look at this particular survey, which is done by Kaggle over a period of time, since 2018 to 2021, they were asking questions to the data scientists, what kind of development environment they were using. If you look at initially in 2018, probably people were using none of the hosted environments. That means this is mostly people who were using the local systems. That primarily means people were installing probably Anaconda most of the times and running the notebooks on the local systems. But people were also using Jupyter Hub or Binder, which is a hosted environment, and Google Colab. But again, over a period of time, you can see since 2018 2019, the popularity of Google Colab notebooks has improved significantly. And of course, besides that, people also use Kaggle notebooks and local systems. And we'll be actually exploring both of them, the Google Colab notebooks and the local systems, right? If you're not familiar with Google Colab, I have a you can watch the Python primer video that I posted last week. The last 15 minutes, I have explained how to upload file to the Google Drive and run from the Google Drive and run the Colab notebooks. So you can actually log into your own Google account. You can upload the notebooks to your own Google Drive and install Google Colab and then run the Google Colab notebooks. If you want to run on the local system, both are possible, of course. You have to install Anaconda. You can download. I have already sent the instructions and the link to download on the Discord group. You can download the Anaconda platform and run it. And how to run the local system, again, I have shown in that primer video. Basically, there are two options are there. One is you can use Anaconda Navigator and then click on the Jupyter Notebook. That is, of course, one option there. And the other option is you can start from the command prompt, Jupyter Notebook, okay, which will, of course, pop up a browser page, and you can from there you can create notebooks or you can run the existing notebooks. Again, a request for everyone to join the Discord group. So all the communications in future will happen there. In Discord group, actually, I have created multiple channels, sir. I'll just quickly show you. For the primer video, I have already shared the link. So I'll just show you now. If you log into the Discord group, I have created 3 channels here. One is called Notes and Resources. This is where I'm uploading all the links. So you can also see the video, YouTube video, and the Python primer slides here. So as and when we complete different sessions, I'm going to upload all the details, the notes, resources, the readings, and all that onto this particular channel. So you can refer here. To-dos, there's a to-dos channel where I'll be posting the assignments and the quizzes, right? So you can actually go ahead and actually look at those quizzes there and assignments. This is, of course, the meeting details, which will be there, the links and all that. You can directly join from here. And of course, there is a general channel which is open for everybody to kind of communicate. So any questions you have, you can communicate here. You can ask questions, doubts, and people who also know the answers to that, they can actually answer the questions here. I will also respond and answer those questions. So you can actually all communicate here and learn from each other. So let's make this Discord group very active, and we can learn from each other, right? So this is going to be the one place where all the communication will happen going forward. Of course, besides the GitHub location where the actual code and data set will be uploaded, right? So you have any questions on this? Okay. So what I'll do now is I will going to start today's session. So in today's session, our key objective is to kind of look at the basic statistical analysis, how the basic statistical concepts can actually help you to find inference, right, from the data that will be useful for decision making and deployments. So for all the sessions, for example, if you go to your GitHub location ML course v1, and if you go to session 1, if you scroll down, i have uh, I have created, and I'll also be creating like this in all the future sessions, right? There'll be notebooks and there'll be a link to open in collab, right? So for the timing, what we'll do is we will directly run in the collab, and to do this, you have to, or you are required to log into your Google accounts, like a Gmail account or whatever, right? So unless you have access to Google account, you cannot run this collabs. So what you can do is, now you can right click on the open in collab and say open link in new tab, right? So this is going to open the collab in the browser window for you. Okay. If you are not logged in, for example, I have logged in my as my user ID. If you are not logged in, it will ask you to log in first, otherwise you will not have access to Google Colab. So what I'll do is, I'm going to wait for a minute here and wait for everyone to open the Google Colab notebook. So once you see this kind of page, I think we are good to go. So what you can do is, you can say done or yes on the chat window, so that I know that you're able to open it. And then we'll go ahead and start looking at the concepts. Please go ahead and open. Right click on the open in collab and open in new tab, right? So I will open. And once you see this page, please go ahead and say done or yes on the chat window, so that I can start the session. So I'll be waiting for a few more seconds. If you find any difficulty, please let me know. Okay, now assume that you all done. We'll get started now. The first thing that we can do is, here you see a connect button here on the right top. You can click on the connect. This is going to provision a VM for you. So Google platform providing a VM which comes with a pre-installed software and Python libraries which are required for data analysis. Most of the library that you will need for the data analysis would already be installed. There will be, of course, there will be few times where we need to install some additional software libraries, which of course will do it. But I would say probably about 95% what is required are already pre-installed here. So we can right away use it. And they are giving, if you hover around that RAM and disk, you can see that they're giving about 12.6 GB RAM machine and about 100 GB disk space, which is pretty good for running most of our tutorials and sessions, right? So once you see a green tick, that means the VM is running. We will actually can start using it. And if you click on this three rows, you can look at the table of content for today's notebook. This documentation actually is created using something called a markdown syntax. Again, if you are not very familiar with the markdown syntax, please watch the Python primer video. I've introduced some of the basics of Python writing the markdown syntax. So today's session, we'll be actually discussing the key statistical concepts. For example, probability distribution, and one of the distribution that we'll be looking at is called normal distribution. What is the significance of mean and standard deviation, confidence interval, and outlier detection? Right now, rather than discussing theoretical these concepts, what we'll do is we'll actually go and apply them on the real world data, so that and how those concepts are actually applied to find insights in the data. That we will look at so that it becomes quite clear to us. So for this, what we'll do is we'll do a stock analysis, right? Stock price analysis. And for this, I have already downloaded and kept in the GitHub location two stock prices. One is ICICI Bank data, and the other one is Yes Bank data. Okay. And I have taken data from the 1st of October 2022 to 7th of March 2023, just 2-3 days back, right? And this data can be downloaded from this particular link here. For example, if you click on the link, right, it will actually take you to the BSE India site. So this is where you can actually download the live data and real world data. So this is comes under market data, and it allows you to download the equity prices, right? You can actually download equity prices or mutual funds and debts and all that. But for the timing, for this particular analysis, we'll only downloading the equity data. Here, of course, you can type the entity that you want to download, for example, ICICI Bank, right? And then it also allows you to download the daily data, monthly data, and yearly data. And for today's analysis, we'll be actually using the daily data. And then you can look at, provide the period for which you want to download. So in this case, you can select, for example, I have taken from 1st of October 2022 to 7th of March 2023, the daily data. Okay, so the daily stock prices data can be downloaded from the BSE site. So what are you going to do with this data then? So we'll explore some of the basic insights, like for example, what is the value at risk? Value at risk is a concept people use in investments. Of course, in this case, we are looking only at the daily data, which can be expanded to weekly investment or monthly investment or long-term investment, so on and so forth. The value at risk basically is when investors make investment on a particular asset or instrument, right? They first look at what is the maximum loss that that we can have when we invest in this particular assets, the maximum exposure of the risk, right? So we'll actually understand that how that is calculated from the basic statistical analysis and how the basic statistical parameters are leveraged for that. Okay, so we can really understand what are those parameters in statistics and how they are actually applied in the real world data. We'll also answer questions like what is the probability of making a certain percentage of profit if invested in a stock for a specified duration of time. For example, if you are an investor, your profile could be you are very you are a risk taker, or you can also a risk averse person, right? Some people are risk takers and some are risk averse persons, right? So risk takers will say, anyway, I'm taking risk. Now, if because higher risk means higher reward and higher return, right? So if this stock has a very high probability of giving me a return of 5% or more, or 3% or more, because I'm talking about daily data, daily stock price movement, not weekly or monthly and all that, right? So depending on that, you can ask this question. So then probably I'll take that risk. There are two stocks. One stock has the probability of making 3% return or more is higher, then I'll take the risk. Sometimes we are risk averse also, right? You can ask questions like, if the stock, the probability of making a loss is more than 3%, that's a negative 3%, then I will avoid that stock investment, right? So these kind of questions you can ask and answer through our basic statistical analysis. So what we'll do is we'll now look at this two banks data, ICICI Bank and Yes Bank, and the daily movements, how the stock price are moving, and based on that we will calculate some of these key insights from the data. Okay, so that's a context of the problem. Now let's look at the data a little bit. When I downloaded data, it has all this information. For example, it has information like date, right? On a particular date. This is actually in a from the latest to the oldest data. You can see that from March 2000 to October 22. And it also gives you the open price and the close price and the daily high price and low price as well, right? And you also have information like how many number of shares were traded, the total turnover, and so on and so forth. Okay, of course our analysis will not involve all this information. Our analysis will involve mostly on the open price and the close price. So how much the stock is moving every day, and what kind of characteristic the stock has, from that movement we are going to infer from the data. And as you can see, this is a CSV data, which is comma separated values. You must be aware of the CSV files. The first thing that we'll do is load the data, right? So Python Python ecosystem has three core libraries, right? One is called Pandas library. One is matplotlib and one is Seaborn, right? So these libraries you'll be probably using day in and day out when you're doing data analysis, right? Pandas is the library that will actually help you. So if you click on the link on the Pandas homepage, this will take you to the Pandas library. So this is the tool, or this is the library that will be used to load data from different sources like databases or local system and all that, and different formats also, like a CSV file, Excel, JSON and all that. And also helps you to primarily do a lot of data manipulation, like for example, like typical SQL kind of work, aggregation, filtering, joining, mapping and all that, and data cleaning activities, right? We will look at, of course, very advanced concepts of pandas over the next few sessions. I'll start with on the very basic example today, but this is the library that probably will be using throughout all the sessions, right? So this is the first library that will be utilizing when you're actually doing data analysis. Then there are two other libraries called matplotlib and Seaborn. So these are libraries which will be utilized for drawing charts and plots, right? So I will be introducing 2 or 3 plots in today's session, and then of course going forward we will explore at least 10 different types of plots and how those plots can actually give you insights into the data, and how you can take decisions based on what the chart or the plot says. There are 2 libraries which are required for visualization. This is primarily for data loading, right, and data cleaning. right, or data manipulation. These are basically your visualization libraries, right, for doing charts or plots, right. Matplotlib is little low level library. We'll be using it, but our main focus would be Seaborn library. Seaborn library is actually built on top of Matplotlib, and it gives a very abstract API to do most of the charts and plots in a single line of code, right? But sometimes we have to go back to Matplotlib to do some kind of manipulations or settings and all that. I'll show you some of the examples today, and of course in future sessions as well. The first thing that typically we do is import all these libraries, right? So import pandas, uh, import matplotlib and Seaborn, and we use this alias like a PD, a PLT, SN to kind of not use the full name but the small aliases throughout the code. Now let's run the first line of code. You can do Control Enter, or you can also use this play button to execute the code. Okay. If you have any questions, please post it on the chat window, or I'll in between after 10-15 minutes I'll ask you if you have any specific questions, right. You can check the library versions. Library versions are very important because when you build model and deploy it, typically the version number has to be same. So it's typically a good idea to always look at what version of libraries you are using. And to check the version of library, you can always use this predefined variable underscore version underscore. For any library, this is actually defined, the version number. So in this case, we can see the pandas we are using 1.3.5, Matplotlib we are using 3.5.3, and Seaborn about 0.11.2. Okay, few discrepancies will be there maybe, but it's okay. There should not be a major incompatibility in the version numbers. The first thing that we'll do is load the ICICI bank data, right? So for that, you can do PD read CSV, and I have given a link here. If you click on that, pandas provides predefined functions for loading different kinds of data sets, like a CSV file, JSON file, XML file, Excel file, right? Parquet, ORC, significant different file formats. Okay, you can actually go look at the specific function. So both the formats, we have something called read and to. So read is going to read the file, and to is going to write to that particular format. Let's say you have something data in memory and you want to now save it into a file. You can also do to CSV, to JSON and all that, right? So here what we'll do is we will read the data set, the ICICI.csv, which we downloaded from the BSc India site. And the data set actually has a date column. So by default, when you load the data, it loads the date as a string because it does not know it's actually date column. So you can actually specify there's a parameter called parse date, saying that there's a column called date which has to be treated like date and timestamp. So it automatically understands the format and loads the data. So let's execute that. And once you execute, the data gets loaded into a variable. And what is this variable now? You can look at type, which tells you what kind of variable it is. It's actually pandas data frame. So pandas own implementation of data frame. So data frame is a concept which was initially introduced by, I think, R, and then has been adopted across multiple different languages, especially for data analysis. So what is a data frame? A data frame is nothing but a two-dimensional table of rows and columns. So you can imagine like data frame is like an in-memory table which arranges the data in terms of rows and columns, right? The rows are mostly indexed and the columns are named. named by the first line of the data file, CSV file in this case. If there is no header there, then of course you have to read like a no header and provide the header later. There's an option there also. If you want to know a little more about data frame, you can always go to the link and read about it. But it's primarily a two-dimensional table with rows and columns. In this case, more like an in-memory table. Okay. The reason is most of the people who do data analysis are very comfortable or familiar with this kind of concept, right? So they actually this particular structure of the data is leveraged here. So you can look at a few records. So once the data frame has been created, you can say head 5. You can look at some of the records here. The first 5 records that we saw in the CSV file, you can see the records here. The same thing that you can see. You can also look at how many rows and columns, what's the dimension of the data. There is a variable called shape which gives you the dimension of the data frame. And if you remember, this is actually a tuple. So the tuple has round brackets. And the first element in the tuple is the number of rows here. And the second element is the number of columns. So 107. So in this case, 107 means what? 107 days of trading. So this stock has traded for 107 days in those 6-7 months, right? And all the data is there. And 13 columns is of course 13 pieces of information here. We can also do something called info. Info gives you a little more details about the data beside the shape. So give me a second. Okay. So info gives you little more information about the data. For example, it also tells you what are the columns, and in those columns, what are the non-null count. Non-null count means how many records have a field values or non-null values. This also gives you the indication initially how many missing values might be there in the columns, right? But right now you can see except two, for example, delivery quantity and delivery quantity to traded quantity, right? These two columns, rest all columns have all the data. Now, if there are missing values there, how do we deal with and all that? We'll explore that in future when you go to a little more advanced topics about machine learning or data analysis. But right now, because our focus is only on the open and close price and the date, I think we are good enough. We have all the data. And there is also a data type which was inferred automatically by the pandas library. Because we told the date column has to be treated like a date column, it actually created a data type called date and timestamp. And then all the prices columns are in the float values and decimal values, right? It also tells you how much memory it actually utilizes to load the data and all this information. It's more like a metadata about the data frame. Now, this data is little different than typical data that we deal with also in data analysis. This data is a time series data, right? So the data is actually sorted by time. So every record or every column belongs to a particular date. So when you encounter time series data, it is sensible that you create an index. So right now the index is what? It creates automatically called 0, 1, 2, 3, which is a sequence number. It automatically creates out of the data set. But when you're dealing with time series data, it makes a lot of sense to basically set the date as the index. So this will ensure that the data is, you know, properly sorted by the time, right? So you can actually change the index of the data frame by saying set index, but this is primarily used only if you are dealing with the time series data. Otherwise you don't normally do it, and you have a proper times column or date column. So you can set index, and drop true means now once you set this particular column as an index, now we don't need the column anymore. You can directly look at the index and look at the actual date. So if you do this and look at the data now, we can see that the date column has moved as an index now. And this is, in our case, of course, our data is sorted by time, but in some cases, the data is not sorted by time, and you use the date to be an index column, by default it gets sorted, right? And currently it is sorted by what? Descending. For example, it goes from the current time to the old times, and you can change that by changing the order. For example, I am asking to sort the index in ascending order. That means start from the October, then November, then December, January, and so on and so forth. And I'm going to sort that. And whenever I'm doing a sorting, or whenever I do an operation on a particular data frame, it always returns a new data frame after the transformation, right? So what might happen is, as we keep on doing many different operations like this, we'll probably start creating many different data frames in memory, right? Which is not a good idea, because you'll start consuming a lot of memory. So sometimes what we want to do is, we just want to make changes to the existing data frame, and we don't want to retain the old one. Then in that case, what you can do is, you can have a parameter called in place true. Most of the transformations that data frames you do, there will be a parameter called in place, saying that you change in the existing data frame, do not create a new data frame. Okay? So in this case, when you make a changes, you don't have to assign back to a new data frame. For example, in the previous one, when we change the index, we assign to another variable. Of course, we overwritten this variable here, but we could have actually written to a new data frame or variable. But in this case, we are saying that you make the changes here as well. Okay. Most of the times we use in place true. And once you do that, we can start looking at the data frame records. So head will actually give you the first 5 records, but we can specifically ask to look at a slice of the index, right? Like if you remember in Python, we can actually look at the slice of the collection. So you can also look at the slice of the data frame. So here basically saying that show me from the record 0 until 5, not including 5 is always excluded like that. So 1, 2, 3, 4, 5 records. So you can actually show from any specific records actually. You can also give the date slicing as well. We'll look at that later. You can also look at the last few records using negative indexing. This is same as your Python collection itself. So what are the last 5 records? You can say -5 colon as well. Okay. So for this particular analysis, what we'll do is we will only look at the close price and open price. So we're going to select only those 2 records here. So data frame, close price and open price. We will only select these 2 columns. So when you are slicing a column, then you have to give the column names as a list in the index. So if you see the 2 brackets here, the internal bracket is basically the list, and then the outside one is the for indexing. So this is going to only select those 2 columns now, and our whole analysis will be based on this 2. Now let's load the data for the yes bank as well. So this is we are done for the ICICI bank. So here again we'll read the CSV file, the yes bank file, set the index, sort the index, and again choose the close and open price and look at the data. The first thing that we'll do is we'll calculate the daily gains of each of the stock. That means every day how much the stock has gained from the open price till the close price. Right? So you can actually calculate the gain by saying the close price minus open price divided by the open price multiplied by 100. So we're going to calculate that in terms of percentage. And data frame supports the basic arithmetic operations like ICICI DF close price minus ICICI DF open price divided by the open price and multiply by 100. Right? You can actually write the equations like this, and you will assign to a column called gain. Right? So this is a new column that's called this is a new column that is computed now. So on this particular day, which is the 3rd of October, the stock has actually has lost 1.38%. But on this particular day, the stock has gained 1.76%. So open price and close price. Right. The same thing we are going to do it what? We are going to do on the yes bank as well. So they're calculating the gain for both ICICI Bank and the Yes Bank. Now what we'll do is we want to understand couple of things, right? We are going to calculate what is the risk, the value at a risk for both the stocks. Right? For that, let's first do what? Let's look at the trends first, the historical trends. How the stock has moved over a period of time. Right? So to do that, we can use the matplotlib library, and there's a function called plot, plt.plot, and we'll only look at the close price, right? How the close price has moved from day in the last 6 months. So you can actually see how the prices has moved over a period of time from the October to the March times. And you can also change the size of the plot by doing something called fixed size, right? If you set fixed size, this is actually the width and the height of the image or the plot. This is actually in terms of inches. If you look at the documentation, it basically says the width and height in inches. And you can also look at the close price of Yes Bank, and you can see the stock actually has gone up until the period of 2020 to December and January. I think since then the stock has tanked, and there's some recovery here, and the same thing, almost same pattern here. And you can both the stocks have almost reached to the levels of the October times last 6 months, right? So from December 2020, the stock prices have fallen and reached the October 2022 levels. Okay. Now, if you this is of course over a horizon of 6 months and all that, but let's say you are mostly an investor who's looking to invest in the stock for a day, and you are seeing, okay, how much I can make money or how much returns I can make by investing in the stock in a particular in a day, right? Like a day trading. We'll also expand this idea to monthly and weekly and quarterly and all that later, but for the timing, let's focus only on the daily trading. The first thing is we look at how the stock gains, everyday gains look like, right? So what I do is, instead of plotting the close price, what we'll do is we will actually plot the gains. PLT plot ICICI DF gain. So let's look at the gain of every day. And now we can look at how the stock prices move every day. in terms of gain. And you can look at that in ICICI stock, of course, it's centered around zero mostly. And the typical trend that we see, the stock, of course, moves in either direction, either the gain or the loss, and which is kind of fluctuates continuously. Some day it is gain, some day it's loss, and so on and so forth. And the stock typically moves probably maximum about 2%, not more than that, or loses also more, no, about 2%. Okay, there are specific days where the stock has gained more, or specific days where the stock has lost more, but most of the times the stock has gain or loss has stayed in between 1 or 2%, not more than that. Okay, this also kind of tells us one key concept of stock, or key attribute called volatility of stock. Volatility, right? So the stocks which are highly volatile are typically assumed to be high risk stocks, and the stocks which are less volatile are considered to be less risk stocks. Okay, of course, um, uh, it has a different take on from the investment perspective, which will look at some of the key concepts now. But if you look at the same thing on ESDF gains, now you can see the Yes Bank again, of course, hovers around zero, and the stock, of course, few days has gone up and few days has gone down, and so on and so forth. But sometimes we actually see it has gone almost to the level of 5% or maybe 4%, quite a few days. The loss is also quite a few, about 4%. And of course, there are specific days it's gone up to 10%, and so on and so forth. Okay, which kind of gives us some indication that the Yes Bank is little more volatile compared to the ICICI Bank stock, right? If you have to observe the scales here, that's very important, right? And if you look at the mean and max gains, for example, ICICI DF gain, by the way, you can also access the column name as a dot. The column is actually added as a member variable to this object. Either you can access by index and double quote like this, right? Or you can also access by dot. The only problem is if you want to access by dot, the variable should not have a space in between. If there's a space in between the column name, then you have to access by the index. Okay. Now, what is the mean and max gains that we observed in the last 6 months? The mean is the maximum loss is about minus 3.3% that we have observed in a particular day, and the maximum gain is about 2.7%. But if you look at the Yes Bank, it has quite high actually. So in certain days there's a minus 8.48 and then 12% gain. Okay. So volatility is the rate at which the price of a stock increase or decrease over a particular period of time. So in this case, of course, we have taken daily gains, but you can also calculate the volatility in terms of weekly gains, monthly gains, the quarterly gains, and all that. And I will show you how to prepare the data for that in the next session for different periods. But we will complete for daily movement today. The higher stock price volatility often means higher risk. Okay, and of course, it actually helps an investor to estimate the fluctuations that may happen in the future. The whole idea is if you're looking at a daily trading, and if you look at how the stock has moved in the last 3 to 6 months, that gives you some kind of indication. Of course, you cannot look at a stock for last 5 years and 10 years and then calculate the volatility in terms of daily trading, because the stock might have changed in its behavior, right? But in the short term, you can actually look at the volatility and understand the risk involved in the short term investment, like a daily trading, right? For this, of course, we have taken only for 6 months of data to understand the behavior of the stock itself. Now, this is, of course, looking at a very high level what's a mean and max gains, but we also want to understand in this particular stock, all right, how many days the stock has given, let's say, 0 to 1% return, 1 to 2% return, 2 to 3% return, or 0 to minus 1% loss, minus 1 to 2% loss, right? So in each of the bucket, out of this 107 days of data, trading data that we have, what is the maximum frequency, right? Where the stock has most of the times has given 1 to 2% return, right? Or it has given 0 to 1% return, and so on and so forth, right? So for that, what we have to do is all these gains that we have observed here, all the gains, right, which kind of vary every day, we can actually create something called bins or buckets. So what we'll do is we'll create bins like 0 to 1%, 1 to 2%, 2 to 3%, and minus 1, minus 2, and all that, and look at each bin, the frequency of the price movement, right? So for that, what you can do is you can create something called histogram, right? So how many times in terms of frequency we're observing different values of gain and loss, right? So you can actually create a histogram which primarily used to understand the distribution behavior of a numerical variables. Again, we'll come back to that little more detail when we go to advanced topics. But for the timing, let's focus on this one. Say, for example, saying how many days we have seen minus 2, minus 1% loss, minus 1 to 0% loss, 0 to 1, 1 to 2, and so on and so forth, right? So then what to do is we can simply draw a histogram by saying plt.hist, okay? So hist stands for histogram, and you just have to specify the variable, the gain. So this creates a histogram for the gain variable of ICICI Bank. And in this histogram, the x variable is the gain, okay, and y is what? The frequency. The x is the gain and y is the frequency. And we can look at in each of the bucket, like a minus 3 to 1, minus 2, minus 2 to minus 1, 0, and all that. But if you look at this is not properly aligned with minus 3 to 1 and all that. The buckets looks very different, isn't it? That's because the default histogram creates bins in a very different way. So what it does is it looks at the max value of the variable that we are trying to plot, in this case the gain, minus the minimum value. So if you remember, the maximum mean is what? The max is minus 2.7 and the mean is of course minus 3.3, and then divide by 10. So whatever that mean to max range, right? So the max to minus mean and divide by 10, it creates 10 bins. So whatever the width it comes, it uses that width for the each of the bin. Of course, this is not a very readable. So what we'll do is, in our case, we will actually force the bins to be as we want, right? We will actually force the histogram to create the bins the way we want. So we'll actually do histogram now with ICICI gain, and the bins will create a sequence of numbers. So remember, we use a range function in Python. I introduced in the Python primer. So what we'll do is, in this case, we'll create a sequence of bins starting from minus 4 to 4 with a width of 1. So minus 4 to minus 3, minus 3 to minus 2, until 3 to 4, and so on and so forth, right? We're forcing the bins to be created like this. This will be, of course, much more readable now. right? So here it looks appropriate. So you can see -4 to -3, -3 to -2, -1, so on and so forth. And we can see that the stock has, you know, encountered huge losses very few times, probably 2 or 3 times only, right? And we can also see that from the plot library. Most of the time the stocks gains have remain between -2 to probably 1% or 2%, and the maximum times is still about 0 to -1%. So most of the times maximum frequency out of the 107 days, about 40 days, it has actually lost somewhere between 0 to -1%, and then 0 to 1% gain, and so on and so forth, right? Similarly, if you look at the histogram of the Yes Bank, it also looks similar to that. So here also we have created a bin from -2 to 12, let's say -9 to 12, because if you look at the mean and max value of Yes Bank, it was -8.48 to 12%, 12.6. In fact, we should have done it probably 13. Okay, you can change it. Yeah, that'd be nice. So you can see there are certain days, probably just 1 day or 2 day, the stock has actually seen a huge gain and a huge loss. Not sure why. You have to go and look at relate this with the, you know, what's happening right in the company, and probably for the news and all that relate. But most of the times you can see the stock has actually gained 0 to 1%. In case of ICICI, most of the times we have seen actually loss of 0 to -1%. But here most of the times we have seen about 0 to 1%. But that's again only 35 days out of 107 days. And then quite a few times we've seen more losses than gains actually, additional gains, right? So if you plot a particular variable value, right? For example, in this case, the variable is nothing but a gain, okay, and the frequency of it, okay. So this will kind of tell you the behavior of the variable, okay, of the variable. So in this case, the gain is also kind of called the distribution of the variable itself, right? So this is also called the probability distribution, because if you look at the total frequency, if I ask you now, just for the sake of it, what is the probability, right? What is the probability that the ICICI stock, what is the probability that ICICI stock will actually give me somewhere between 0 to 1% return? Okay, so that will be nothing but, okay, they have nothing but what? In this case, let's call this around 40, right? So 40 divided by what? Total number of days, isn't it? Total number of days. We know that there's about 107 days of trading. So that is going to the probability value for the ICICI stock. Sorry, this is wrong. This is what is the probability that the stock would give me 0 to 1% return, right? It'd be around this one, not that one, right? So this will be around, let's say 30. So it'll be around 30 divided by 107, right? 0 to 1% return. What's the probability that the stock would make a loss of 0 to -1%? So that would be around 40 divided by 107, and so on and so forth, right? So this plot typically gives you the probability distribution of the variable, right, for different possible values of the variable. So the probability that will make a loss of -3 to 4% is very minimal. If you look at probably just 1 or 2 out of 107. So the probability that will make such a huge loss is very unlikely. Okay, but the probability that you will make a loss of 0 to 1% is very high, right? Almost 1/3, right? So if you randomly invest in the ICICI stock, for a daily return, let's say you randomly 3 days you invest. So one of the day you will actually encounter a loss of 0 to -1%. That's basically the whole inference here. So what we do is we now kind of um, reduce the bin. You can imagine like that. If you reduce the bin size to very small value, right? So the bin size becomes extremely small, then this will start appearing like a smooth curve, right? So this is nothing but your called your distribution plot, or probably the kernel density estimation plot. This is also called KDE, which stands for kernel, right? So kernel density estimation plot. Okay, so here the difference is now the y is not a frequency anymore, it's actually a density. Okay, what a density means? So density means basically the kind of, you can equate to probability value, right? So what is the probability that the stock would make exactly -2% loss? Then you can calculate the probability here. But what is the probability that it will make between -2 to 0% loss? So that will be the total area under this particular curve, right? So you can look at the KDE plot for the ICICI Bank, and you can see that a nice bell curve kind of shape is appearing here, right? A bell curve. You must have heard bell curve quite a few times, right? Especially during the appraisals, right? So this looks like a bell curve. Now we'll look at the properties of this particular curve and distribution now. Similarly, you can also plot it for both the stocks now. So to do that, what you can do is you can plot both the KD plots in the same cell. So if you plot both the two plots in the same cell, they'll be overlapped on each other. So in this case, ICICI Bank and Yes Bank. And because they're overlapped, we will not get to know which one belongs to who. So you can actually specify a label for that, like a Yes Bank and ICICI Bank. And then you can create a legend. So legend is basically what you see here, right? So if you say legend, you will get a legend. So then you can distinguish which car belongs to what, right? And then I will providing a title as well, the stock here, right? So you can see the X is gain, Y is density, which is nothing but a frequency. So this is basically it calculates at every possible value of the gain. For example, 0.0% return, no return at all, 0.1% return, 0.2, right, 1.0% return, 1.1. You can imagine like that, continuous value. Then it draws the plot like that. Right. And one important observation here, if you look at the difference between the ICICI Bank, which is in the blue line, and the Yes Bank, the spread of the distribution of the plot is higher compared to the ICICI Bank. Okay, so this spread is nothing but it's called dispersion of the curve, right? So that basically shows you the variance, which of course we're going to calculate now in the data. Okay, and one observation is the stock which has a higher dispersion, right, which has a higher dispersion typically is a higher volatile. So you can actually plot and overlap stocks daily returns, and you see, okay, the stock which is a higher dispersion, there's another stock which shows something like this, then that is a higher volatility, right? We observed, for example, in case of ICICI stock, observing a -5 return or loss is almost zero, but there is a possibility in the Yes Bank, right? But can we actually measure this? Is there a metric to measure the dispersion volatility? Then we'll come to the look at the distribution here itself. I'll just wait for a 30 seconds here. Do you have any questions so far? Are you all able to execute the code in the notebook? You can say yes or done on the chart window. Just want to ensure that you're able to execute. Thank you. So when you plot a particular variable and its density or frequency, right, there are possibilities that some, for example, a particular variable x and its density, in this case the frequency. So some plots would look something like this, whereas some plot would look something like this. In some cases, the plot might actually look like this, and so on and so forth, right? So for different patterns in the density, we relate them to different kinds of distributions. Yeah, I'll come to that. So somebody asked a question saying that, can you explain the range -3 to 13, -9? So you can actually see this -9 to -8, right? Sorry, -9 to -8, -8 to -7, 6, so on and so forth. So each one, it actually belongs to one. So in this case, probably from -9 to -8, -8 to probably -7, both we are seeing the same kind of frequency. That's basically showing like that, right? So this will be -9, this will be -8, -7, -6, and so on and so forth, right? Each one. So here also I probably -4 and -3, we're seeing the same kind of frequency. That's why I'm seeing a little longer here, right? So each one actually is one bin here. Is going to create. So -1 to -9 to -8, -8 to -7, until 12 to 13, right? So 10 to 11, 11 to 12, and 12 to 13. So each of those patterns in the distribution of data is actually related to one kind of uh, distribution. Okay, so when the data looks like a bell curve like this, it's typically related to normal distribution, right? So normal distribution, also known as the Gaussian distribution, is the most important probability distribution in statistics. Okay, so most people recognize its familiar bell-shaped curve, right, in statistical reports. Okay. Quite a few variables in the world actually follows normal distribution. Of course, there are 40 or 50 different major distributions are there. We are not going to explore all of them, probably a couple of them. But normal distribution is something that you should be very aware of, and quite often it is used for analysis. And all the distributions have a few parameters. For example, the normal distribution, when you see a bell curved shape, right, it actually has two parameters. One is the mean value of the distribution. The other one is called standard deviation or variance of the distribution. The two parameters. In fact, all distributions has three parameters. One is called the location parameter, where the distribution is located around, right? Then there's something called scale, right, which is a dispersion parameter. And the third one is called shape parameter. So all distributions have three core parameters called location, scale, and shape. For normal distribution, the shape is fixed. It always looks like a bell curve, right? In some distributions, the shape also keeps changing. the location scale changes, right? But for the normal distribution, it always looks like a bell curve. And the location is basically the mean value, and the scale, the dispersion is nothing but your variance or standard deviation parameter, right? For example, if you go and calculate, I'll come back to this plot now. How do you calculate mean and standard deviation? I think you must be very familiar with notations here, right? If you're not, I think it will go and explore that. So the way we calculate the mean value of the sample, the mean value of the sample is always written like x bar, right? Because we don't have all the data, right? All daily data. We have only 6 months of data, the sample, 6 months of sample data. Then xi, we submit all the values of x and 1 by n. And the variance is what? Variance is how each of the value varying from the mean itself, right? So xi minus x bar square and submit and square root 1 by n. Sometimes you do n minus 1 for a degree of freedom, but for the timing, don't worry about that. So this is called your mean, this is called your variance. And the square root of variance is called the standard deviation. Right. So you can go and calculate the mean value and the standard deviation of it. The mean comes out to be at an average. If you look at the last 100 sevens of trading data, the daily return data, the ICICI stock, the average return per day is about 0 only, 0.08 negative value, little loss. The most of the times it has a loss only. And the standard deviation is about 1.12, right? Now, a normal distribution has a rule, right, based on the mean and standard deviation. So if you look at the whole area now, look at the whole, for example, let's look at the ICICI Bank, right? Sorry, the Yes Bank. Now, if you assume that the total area that is under this curve is equal to 1.0. What is 1.0? That means the probability that the stock has a return of something minus infinity to plus infinity. That means all possible values, if you calculate the probability values, all will be equal to what? 1. But then what you can do is you can calculate the probability of different intervals. So in the normal distribution, this is one of the most important rules of normal distribution. Sorry. Right. That means most of the values for the gain is centered around the mean value. That's why you can see around 0. That means most of times you have actually observed there is no return, no gain or no loss on a daily trading, or probably somewhere around 0 only, very close to 0. But when you look at more and more number of days, right, we can see the values are varying from 0 to probably going to -1, -2, or +1, +2. So if this is your mean x value, and if you go one standard deviation to the left and one standard deviation to the right, so in this case, if you look at the ICICI stock, so currently the mean is on -0.08 and the gain is about, standard deviation is about 1.12, isn't it? So if you look at, let's consider this to be almost 0. This is 1.12. So -1.12 to +1.12, right? And if you look at the area between these two particular values, -1.12 to +1.12, -1 standard deviation to the +1 standard deviation, this area will be around 68% of the total area, around that, right? Which means in the sample, right, out of 107 days, right, 68% of the time, okay, whatever that value is 107 days, right? 68% of the times, the stock's daily gains were between minus 1.12 to plus 1.12. So that we can conclude. That means almost 70% of the time the stock has remained between almost close to minus 1 to plus 1. And if you go to two standard deviations and to the left and right, that means this will be around 2.24 minus, and this is plus 2.24. Now this total area, now from this area total, this will be around how much? This will be about 95%. Okay. Of course, based on the value, there will be few differences will be there, but most likely will be around that 90%. That means what has remained between the stock price movement, daily movement, it has remained between minus 2.24 to plus 2.24, 95% of the times, right? Which is typically also called the normal trading days, right? Normal trading days. And if you go to 3 standard deviation, which is minus 3.36 to plus 3.36, right? That area, that total area would be about 99.7%, right? So if you look at this plot here now, this says that that's of course X bar, talking about population parameter. So now if you go to the first standard deviation, this will be 34.1, 34.1, that's about 68.2%. Now if you go to two standard deviations, the total area would be 95%, and the three standard deviation will be around 99.7%, right? In fact, any value that's beyond 3 standard deviation left to right are typically called outliers. Okay, we'll of course look at some of the application of outliers in a couple of examples. So the value, the range of values between this actually is called a confidence interval. This is called what? The confidence, the interval of 95%. So 95% of the times the value of the variable lies between which value to which value, right? So you can actually calculate that interval. The confidence interval is a range of values bounded above and below the mean value. So you can say, if you look at the bell curve, you can say 95% of the times the value lies between what to what? This value x1 to x2, let's say, or v1 to v2. Okay, so this is called your confidence interval. Most often used confidence intervals are 90% or 95% or 99%. How do you calculate that? Based on the rule, we can always calculate by doing a plus or minus standard deviation, but that's only going to give you the 68% or 95% or 99.7%. The specific intervals you can calculate. You can calculate a specific interval actually. Any interval, for example, you can specifically say, okay, what is the 50% interval? 0.50, right? So if you want to calculate the total area, right? I'll come to how does it actually calculate later. The total area. So he looks at, if you say 50%, what's at 25% this side of the mean and 25% of that particular mean. So then look at what is the value. The interval, the 50% confidence interval of the value is between V1 to V2. Okay. It calculates the area. Okay. So now let's look at the 90% value. And now you can actually use a library called SciPy. This is also an interesting library in Python, which primarily used a lot for statistical inference, right? So a lot of statistical uh, analysis for distribution parameters and all that, you can actually use this library. It also can be used for hypothesis testing and all that, which will of course explore later. Okay, there are questions here. One is all the standard deviation discussion is only concerned distribution. No, standard deviation is actually the variance is actually across quite a few distributions, most of the distributions, but the way we calculate is very different compared to this. If the data is other distribution, then you have to follow the rules of that particular distribution. We'll explore a couple of distributions in this course, not many, and then we'll look at that. Okay. So let's first understand one basic, most important distribution, and then we'll look at some other distributions later. So the scale parameter, like I told you, all the distributions have three parameters, right? Location, scale, and shape. The scale is primarily the variance of the variable, which is applied to almost all the distributions. The only thing is the way we calculate the mean and variance. This is applicable only for the normal distribution. Okay, so the other distributions have a different way to calculate the parameters. So if you look at so this particular library, if you call stats dot norm, so norm stands for normal distribution. Similarly, stats has many distributions actually. So if you look at if I do like a stats dot, right? Let's say I say, I don't know. Yeah, you can see gamma distribution. Okay, or you can also see there is a exponential distribution, right? Or there'll be beta distribution, right? Or there'll be a Poisson distribution, right? So the different distributions are, the distribution are already inbuilt into this library. Now based on the distribution that you are exploring, you can actually invoke that and then calculate the interval. Again, interval is a concept in all the distributions, right? Based on the scale of the distribution itself. But for this normal distribution, you're saying, can you calculate the interval for 0.9, right? And then you're specifying two parameters, location and scale. Remember, I told you that two parameters are there. You can say location. In this case, the location is mean and the scale is standard deviation. So then it comes back and tells you for 90 confidence interval, the value would lie between minus 1.9 to 1.75. Right? That means around the mean, 45% this side and 45% this side, right? The value is been minus 1.9 to 1.75. Okay. So 95% of the 90% of the time, the value has lied between what? Minus 1.9 to 1.7. And this is the remaining 5%, and this is the remaining what? 5% here. So the other losses or gains that you have observed is only 10% of the times. Out of that, maybe more than minus 1.9% you have observed only 5% of the times. Sorry, less than minus 1.9, and more than 1.75% gain you have only observed 5% of the time. That you can conclude, right? Now let's look at how this is applied to the value at risk. So value at risk is actually a statistical concept which is actually utilized in the risk management to predict the greatest possible losses over a specified time frame. What is greatest possible loss? That means we're talking about daily gains here, right? So if I invest money in a ICICI bank in the morning, by evening at the close price, what is the maximum loss I can have? Right? Let's say I want to invest 1 lakh rupees in ICICI bank in the morning, open trading, and by evening, what is the maximum loss I can have? Right? Somebody might say, well, if you invest in 1 lakh rupees, by evening you can actually lose all that money. But that's not possible, right? Because we have never observed that kind of scenario by looking at the past data. Nobody has lost that, right? So what's the maximum loss? So maximum loss is actually calculated like this, right? So what they do is they look at the distribution and say, instead of actual returns, here we look at the worst 5% of the normal curve, right? Some people also look at 1%, but most people look at a 5%, right? So they look at 5% of the times what is the maximum loss that has people have encountered. So you can see that the maximum loss is about minus 1.3 here. Right. So that means if you look at the 90% confidence interval, this is 45%, this is 45%, right? This is 5%, this is 5%. So this signifies the 5% of the worst possible scenarios the stock ever encountered. And as you go further to the left, it becomes a rare and rare event. Okay, so you can see that this is probably the highest possible occurrence, okay, in that 5%, right? So we'll look at this particular value, and that we take as the greatest possible loss. Okay, the greatest loss that you can have. So value at risk is calculated at that particular point. So if I invest 1 lakh rupees, okay, so the maximum loss that I can have is what? Minus 1.93, which is nothing but the first value of it. I can calculate and say the maximum loss that I can have is probably about 1,930 rupees. Similarly, what they do is, of course, this is one basic analysis. There are many advanced analysis out there. So they look at each of the stocks, right? Let's say you're a risk averse person, right? And you want to invest in stocks for a daily trading, about 1 lakh rupees. And then the maximum loss that you can tolerate is, let's say, 2,000 rupees. You don't want to lose anything more than that. Then what you can do is you can calculate the 5% for, let's say, stock 1, stock 2, stock 3, stock 4, and all that. And out of that, you can eliminate those stocks which has a higher probability of 2,000 rupees loss. And then you can only select those stocks which has a less than 2,000. For example, in this case, you will probably choose ICICI Bank. Right? The same thing can calculate for Yes Bank also. You can calculate mean, standard deviation, and you can look at the loss, the 90% confidence. And here it's about minus 4.8. That means there's a possibility that you can actually make a loss of 4,859. So if your tolerance level is only 2,000 loss, not more than that, then probably Yes Bank will not be considered as a candidate investment, right? So Yes Bank has a higher risk of higher loss, but then remember, the stocks which higher risk also provides higher opportunities also for higher gains, right? Because in a Yes Bank you can actually make a gain of 5%, but in ICICI Bank you can never make a gain of that kind, because maximum gain that you observed is probably 1.75% in the 90% confidence interval, right? The stocks which are higher volatile typically also provides opportunity. So volatility is always not a bad thing. It all depends on the investor's profile. it sometimes provides an entry point from which investors can actually take advantage of it, right? But then you need to understand that particular aspect and calculate that, and based on that you can decision. Okay, so far so good. I'll just wait for 30 seconds here. Any questions, or you can move ahead? Now let's ask very specific question. That's a maximum value loss, right? Now you can ask very specific questions. For example, you can say, what is the probability that the stock will have a loss of 3% or more? Right? So now you consider a set of stocks and say, what is the probability that stock 1 will make a 3% or more loss, right? Stock 2 will lose 3% or more, and stock 3, and so on and so forth. Then out of those, let's say 20 candidate stocks, what you can do is you can say, because this stocks has a higher probability, we can actually eliminate them, and you can only choose the stocks which has a lesser probability of making 3% loss on, right? So if you look at the KD plot that we had done earlier, so in this case, now if I ask you what is the probability the stock will make a 3% or more, so then this will what? So this probability would be the sum of all probabilities, right? That is 3% or more. But this is actually wrong written here. I will explain that here. Because I'm asking the question, what is the probability that stock will make a loss of 3% or more? So let's say this is minus 3. Okay. So minus 4, 5, and so on and so forth, right? So what is the probability that will make a 3% loss, 3.1%, 3.2%, so on and so forth, right? So all these probabilities, right? The sum of all probabilities will be this one, right? Because I'm asking 3% or more. Okay? The sum of all probabilities will be that. Similarly, if I ask you, what is the probability that stock will make a 5% gain or more, then 5%, 5.1%, 5.2%, that area will actually denote the sum of all probabilities to be there. Right? Following. So, so what we call that? So this area, okay, right? So if you remember, that area can be calculated in integral. Okay, so don't worry if you don't know this, you can ignore this, but I'm just saying that. So value from minus infinity, okay, whatever the value, until minus 3, the whole area, right, the area under the curve, px and dx, right? So basically sum up all the probabilities here. So this is what is called your cumulative distribution function, right? It's called what? It's called cumulative, because cumulatively sum of distributions, cumulative distribution function, or a CDF. This is the probability variable will take a value less than or equal to the random variable. That means I'm saying minus 3 or more. More means basically in terms of less value, minus 4, minus 5, and so on, right? So this is called a cumulative distribution function. It's given by this. In fact, this should be 3%. It's wrong written here. 3.1%, right? 3.2%, and so on and so forth. That's a loss. So this should be minus 3%, minus 3.1%, minus 3.2%, and so on, so forth, right? Highest loss. So you can go and calculate that. So again, under stats, there is a function CDF, stats norm CDF. Remember, we used a function called what? Earlier, interval, which gives an interval around the mean. Similarly, you can also give some CDF. Again, CDF function which is applicable to all the distributions, right? Use a max 3. That means all values until minus 3. So minus 10, minus 9, minus 8 until minus 3, and you can give the mean and standard deviation, right? So this will give you the probability, that area under the curve. So area under the curve basically is saying that 0.004, right, which is a very small value, isn't it? This is almost like, if you in terms of percentage, it will be like 0.4%. So the probability that the ICICI Bank, if you invest on for a daily trading from the opening price to the close price, right, the probability that you will make a loss of minus 3% is very, very low, right? Whereas if you look at the CDF of Yes Bank, it has 0.24. That means almost 24%. That means if you invest in this stock randomly on 4 days, one of the day will actually make a loss of minus 3%. So this is I mean, talked about 3, right? It's written wrongly here. So let's look at 3%, 15%, 15.2%, right? So one of the 6 days. So the Yes Bank has a probability, higher probability compared to ICICI Bank of making a loss, right, of 3% or more. Now, if I ask a question like, what is the probability that the stock will make a gain of 3% or more? Gain means what? So loss is, in this case, the area to the left of the curve. The area to the left of the curve, right? That basically is a loss. Gain will be the right of the curve, right? But the cumulative function always gives you from the left side. It always gives you whatever value that you give. Okay, it always calculates the total area to the left of that particular value. So how do you get the right of the area? Because we know the total area is 1.0. Total area will always 1.0. So if it gives me the right left to the value, I can say 1 minus of that. I will always get to the right of the curve, right? So to get the area under the curve to the right of a particular value, let's say V1, okay, we can calculate the CDF until that value V1 and minus of 1 minus of that. But if you want less than that, and then you can just get a CDF. So here, what is the probability that the stock will make a gain of 3% or more? Probability of a gain of 3%. So 1 minus, you can calculate the CDF. The ICICI Bank has the probability of making 3% or more on a particular day is a almost 0, again 0.2%, right? But whereas the Yes Bank has a probability of how much? 16%. That means there is a higher probability here. That's why the stocks with a higher risk also has a opportunity for higher returns also, right? So now depends on the profile of the investor, whether you are a risk taker or risk averse. Depends on that, you will actually take a call whether to invest or not invest on that stock, right? But to even come to that point, we can actually take data and understand the behavior of the customer, behavior of the stock prices movement, and based on that, actually take certain, we calculate these values and take decisions based on that. So this is what I wanted to cover today, and have kind of looked at the probability distributions, normal distribution, significance and mean standard deviation from the practical approach, confidence interval, and outlier, which is currently the outlier is nothing but the value which lies between -3 standard deviation or x plus 3 standard deviation, right? We'll look at the other aspect of outliers in the next class a little bit, and correlation analysis in the next class. So here, what I'm expecting from you is, of course, there's a link here to explore a few other distributions. You can actually go and look at the distributions. I have a link here. So different distributions are there. You can see this is what we have only explored is normal distribution, right? Let me take a different color. So what we explore the normal distribution looks like bell curve. There are quite a few other distributions like binomial distributions, quite widely used. We look at logistic distribution when you come to logistic regression. Exponential distribution, very popular, quite widely used, and Poisson distribution, right? Of course, I'm not going to cover all of them, but cover a couple of them. And once you get used to, because there are quite a few significant distributions are there, and unless you are really a statistician, you will not be dealing with a lot of these distributions, but you will definitely going to deal with the normal, binomial, and probably logistic distribution, and we'll look at that. Right. So you can click on one distribution like a normal, exploring, and then what you can do is you can give some values like let's say 30, and standard deviation is 5, 4, right? And then you can look at the distribution. This is a cumulative distribution function, and this is the probability distribution function, right? This is the cumulative distribution function, nothing but as you go from the left to right, the area will of course slowly increase, isn't it? So as you go on, the area starts increasing, and when you come to the complete right, the total area will 1 actually. You can see the how the area changes, right? It starts with 0 and then slowly increases until it becomes 1. You can also give maybe number of samples that you want to create, and then look at also the histogram of it. Okay. Finally, there is a participant exercise that you can attempt. So what you can do is you can download the daily stock prices of 4 to 5 different randomly selected stocks. It would be good if all the stocks belong to just one sector. Then the comparison becomes fair. Then what you do is you can find out the value at risk of stock at 95%. So what we calculated, the value variable at risk is at 95%, because we looked at the worst 5% of the scenarios. Then plot daily gains and loss of all stocks in one plot to compare the volatility of the stocks, and then find out the probability of making 4% gain in each of the stock. All right. So let's attempt this assignment exercise, and again you can upload that to your own GitHub page. I can see a lot of people have already uploaded to the GitHub the Python primer, and then share it on the what you can do is this particular plot, that when you draw it, the volatility of stocks with the names, this plot you can actually paste it on the Discord group. Okay. Yeah. So everybody can look at the stock, the risk factor of the stock, because probably I assume that you will have you all will pick up different kind of stocks, so you can actually look at different stocks volatility. So I'm going to stop here. in case you have any specific questions, you can ask me. And uh, what you can do is, alternatively, I'm going to show one. So here I'm loading the data from the GitHub directly. Alternatively, what you can do is you can also load data from your Google Drive, right? So I'll just show you how to do that quickly. So let's say you have the data set loaded onto Google Drive in a particular folder, let's say ICICI CSV, right? Because you won't be uploading to GitHub and give the link, right? Because you are running on the Google platform, it makes a lot of sense to upload to Google Drive and do it, isn't it? So if you look at your collab notebooks, once it's connected, what you can do is you can click on this folder link here on the left, right? One way of upload data is, of course, you can directly upload from here. Can you click on the upload and upload here, and this will of course appear in the uh, folders here, and then of course you can take that path. Every file you can, in the three dots, you can say copy path and then paste it here. But the problem is, if you upload to the VM, once you disconnect the notebook, the data is gone. So it makes a lot of sense to upload to Google Drive, which is going to be persistent storage, and then connect to Google Drive Collab notebook, right? So it has an option to connect Google Drive as a mount point, right? So there's a third link called mount drive. If you click on that, it's going to paste a code here called from Google Colab import drive mount, right? And if you execute that line, right, it will ask you to connect to Google Drive, right? You can say connect to Google Drive, and it'll of course ask you to authorize also. So that you can do, you can authorize. That means you're adding the Google Colab to connect to Google Drive. And once it connects, right, now I can say mounted at content drive. Now you can see type now drive, right? So if you look at the drive here and expand that, is something called my drive. Now this is nothing now your Google Drive, right? And if you, yeah, this is where my files are. I've uploaded to that. And section 1, you see the ICICI CSV file is there. I can actually see the whole Google Drive as a folder structure here, directory here. And what I can do is I can directly copy path here. And now I can paste it here. Right, and if I now load the data, now data gets loaded from my Google Drive now, right? Similarly, you can upload data to a Google Drive and store there and keep linking to the notebooks here, right? Which makes a lot of sense, because right now I've given access to my GitHub location, right? This is of course good for tutorials, but for your own work and all that, it makes a lot of sense to create a folder structure on Google Drive right? And then upload your data and all that, and then give the link to the notebook, mount the Google Drive, and load from there, right? The only thing is, when you run the notebook every time, you have to basically mount it. This is of course not much exercise, just mount it. Or if that is already there, it will automatically authorize and do it. So this is a most widely used way of uploading data to the Google Colab and do it. Of course, on your local system anyway, if I show on the local system, I session one here, and then I can of course click on the notebook, and my data is here in the same directory. And then I can directly say, you know, ICICI CSV and load data from there, right? I can say import and load the data, because load from the local system is going to do that. So give the appropriate path, whether you are on Google Colab or on the Google Drive, load the data and do the analysis. Right? Okay. So there's a question called, where can we get the video repo of Python primer? The Python primer video is on the Discord group, like I told you. If you go to, and there is a, under information, there's notes and resources. There I have given the link here. Okay, so you can click on the link. This is a link to the YouTube. You can watch the video. So thank you for attending the session. Any questions you have, please ask me. Otherwise, we will stop the session, and please do the exercise. I might give a couple of more assignments in the to-do section. Please check it, and you can ask questions, and you have any specific information, you can post in the general channel. Okay, and see the next week. But please watch the video again. I'll upload video by tomorrow evening, and do the assignment. Thank you.